Hello friends, welcome you all. So today's topic is closure properties of regular languages. In this video, we will check all these properties for regular languages, and let's see regular languages are closed under which property. So we will start with the union operation here. So for this, suppose we are given two regular languages L1 and L2. As you know, for each regular language, you can create regular expression as well as you can create finite automata. And if I can create regular expression for any language, that means it is regular language. So suppose these two are already a regular languages. So now I can write one regular expression as A star, and for this I can write one regular expression as B star. Then we need to check whether the union of these two languages is again a regular language or not. So L1 union L2 will represent here the choice between L1 and L2, or you can say we can say L1 or L2. So we can represent choice between these two with the help of plus operator, and you can see, my friend, this is again become one regular expression. So that means union of two regular languages is again regular language. So we can say closer regular languages are closed under union operation. So regular languages are closed under union operation. So I can write here closed for union operation. So now let's take another example, another operation, complement operation. So let's consider L this as already a regular language. Now, if it is a regular language, then we can definitely write regular expression for this. So I can write A B star, A B star. That means it will accept all strings or starting with A, then having any number of B's there, any number of B's there. So I can create finite automata for this language as Q0, which is our initial state, and then we will have A, then we will remove to Q1, and on Q1 we can have any a self loop of B, and that Q1 would be final state. That Q1 would be final state. So now, if I want to create the complement of this language, if I want to create the complement of this language, see, if we represent this particular language in the form of set, so it would be A B, sorry, smallest string would be A, then AB, then ABB, then ABBB, like this. So this would be an infinite set. Now for this particular language, we have created one DFA here. Now you can see, if I want to represent complement of this language, then we we can create any machine that will not accept any of these strings, any of these strings. So how you can create such machine? And simply there, which is very easy. So generally this is made up by changing the final and non-final state, exchanging the final and non-final state. So here in this machine we have Q1 as final state and Q0 as non-final state. So what we can do to create complement of this language, we can create this Q0 as final state as well as initial state, and then we can have A, then we can have Q1 and a complement of sorry, self loop of B here. So now if we change the final state into non-final and non-final state into final state, then this will not accept any strings from this set. This will not accept any strings from this set. That means the this would be the complement. This machine would accept the complement of this language. this machine will accept the complement of this language. And if it is for complement of this language, if we can create finite automata, if we can create finite automata, then definitely it would be a regular language. It would be a regular language. Then complement, we can say complement of any regular language is again a regular language. So the complement of any language we can represent as L bar. The complement of any language L, any regular language L, we can represent as L bar. So if L is regular language, if L is regular, then L bar is also a regular language. Also regular. We have proved that. So by exchanging the final and the non-final state in the finite automata, we can create uh, a finite automata for complement of any given language. Now we will check intersection property. Intersection property. So here we can have the intersection. That means if two languages are there, L1 and L2, which are already regular languages, then we can represent intersection of regular languages, these two languages, as common strings from for both these sets. Common strings for both these sets. Now we can prove this using De Morgan's law, that the intersection of two regular languages again a regular language. Now how we can use De Morgan's law here to prove this? I will show you. See, the L1 is we have been given L1 and L2 as already a regular language. Then we are considering here that the intersection of two regular languages again a regular language. Intersection of two regular language is again a regular language. So we can write intersection of these two. We can write De Morgan's law for this like this. So L1 union L2 complement. L1 complement union L2 complement. We can use this De Morgan's law here. Now, for both the side, if I take complement again, the complement of any given language is again the same language. Like L1 complement is there, and if I take one more complement of this, so this would be again L1 only. So we can take the complement of these two both the sides. So we will have L1 intersection L2, L1 intersection L2 equals to L1 complement union L2 complement, then the whole complement. Then you can see, my friend, if L1 is a regular language, so we have already proved the complement of regular language will also be a regular language. So L1 complement will also be a regular language. Then L2 is regular language, then L2 complement will also be a regular language. Then we have proved the union of two regular language is again a regular language. So complement of L1 complement, union of L1 complement and L2 complement will again be a regular language. So if this particular is regular language, then we are taking the complement of this again. So complement of regular language again a regular language. So that means uh, L1 and L2, intersection of L1 and L2 will be a regular language. Will be a regular language. So I hope, friend, it would be very much clear. We have used De Morgan's law to prove this. So I can write here, it is also closed under intersection operation. So now we will take another property, difference. Difference. So now suppose again we are taking L1 and L2 are both regular languages. So now the difference would be L1 minus L2. L1 minus L2. If we remove all strings of all strings from L1 which are common to L1 and L2, then it would be that as the difference. So now we can represent this difference in L1 minus L2 as L1 intersection L2 complement. So now you can see, my friend, we have already seen that regular languages are closed under complement operations. So if L2 is regular language, then complement of this will also be a regular language. And we have already seen that regular languages are closed under intersection operation. So if L2 complement is regular language, then union of L1 and L2 complement will also be a regular language. So we can use this relation, or we can use the previous properties to prove this, that difference of any difference of two regular languages is again regular language. So we can again write it as closed under difference operation. So I hope, friend, it would be clear to all of you. So now next property we can take as Kleene Star property. Now for this we are taking one regular language L there, and we are now to check whether L complement clean closure of L is again a regular language or not. So how we can do it? See, if L is a regular language, then definitely we can represent this as any regular expression. So I'm writing this as A star B. So now this is the regular expression for this language L. So if it is the regular expression, then definitely we can create finite automata for this. So I can write Q0 here, Q0, and I one initial state, and I can have self loop of A here. Then I can have another transaction there B, and we will have Q1 here, and that would be our final state. So now this is the machine finite automata for this language L. Now, if I make this transition here using epsilon transition, now you can say again this is finite automata, this is finite automata, and now this particular finite automata will accept L star here, L star here. Now, how? See, after reaching final state, again we using epsilon closure, epsilon transition, we can move to initial state again, and then we can again accept the same language. Then on reaching final state, again we can move. So we can have any occurrences of like this, any occurrences of L like this. So this would be L star. And if we can create any machine for any finite automata for L star, then definitely this would be a regular language. So I can write this is closed under Kleene Star operation. This is closed under Kleene Star operation. Now the last property is reversal property. Now, what do you mean by reversal of any language? So suppose we are having one regular language L, and if it is regular language, then definitely we can create regular expression for this. So that regular expression I can take as A positive, clean closure of A plus B followed by AB. That means all these strings, this is the language representing all strings of A and B ending with AB, ending with AB. So now if I want to reverse all the strings of this language, then how I would be doing? So I will write regular expression as BA and any combination of here, right, like this. So now you can see, my friend, here we are having any combination of A and B which is ending with AB. Now the if we want to reverse all the strings of this language, then we can represent them all strings of A and B starting with BA, starting with BA. So for this, I can definitely write regular expression. And if I can write regular expression, then definitely it is regular language. So I can write regular languages are closed under reversal operation. That means any reversal of any language, again a regular language. So reversal of any language we represent with LR, reversal of language L. So L and reversal of L both are regular. Both are regular. So now I hope, friend, you will have clear understanding of all these properties. So if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you so much.